The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone, and welcome to How to Sell Ethernet Extenders. Today, I have Johnny Grant. He is our product line manager for the CopperLink brand. So I'm going to turn it over to Johnny, and that's it.
All right, thanks for the introduction, Jen. So, how to sell Ethernet extenders. I'm hoping after spend the next 45 minutes with y'all, you'll get a better understanding of the use case of Ethernet extenders, how you can profit from them, and how your customers can save a lot of money using them. So, as soon as we get to the next slide, we can begin. There we go. All right, so in understanding the Ethernet extenders, we're going to look at real quickly what are the obstacles for people going IP to get these IP endpoints or these Ethernet-enabled endpoints for applications involving unified communications, IoT or the Internet of Things, or even IIoT, the Industrial Internet of Things. There's certain obstacles, certain hurdles that people have to overcome to be able to get that device connectivity. So talk a little bit about how we're going to overcome those obstacles. I'll go towards the end of the presentation. I'll go over some of the various different solutions that we've done. These are all real-world applications that have used our CopperLink Ethernet extenders. So, any of the devices, our unified communication edge devices, they must be connected to the internet, right? Whether that be either a public or private internet connection, they must be connected to the network. That involves telephony, VoIP, so that's your phones, IP speakers, call boxes, intercoms. For security, IP cameras. I think IP cameras over the last year or two have overtaken the use of the the classic CCTV or analog cameras. Sensors, keypads, these are all things that you'll find in anytime you search for these type of security devices, you'll almost always find an Ethernet-enabled version or a network-enabled. And we're seeing a whole lot of movement towards building automation, putting everything up onto a network. For residences, that's things like the Nest. Well, businesses and retail, they have to do the same thing. So major HVAC controls, thermostat, even lighting control is all going IP based. So resolving those physical connectivity issues can be very costly, although sometimes outweighing the benefit of the UC. Next slide will go into a little bit more about that, but the biggest one being that the premise cabling must be suitable for Ethernet. So that requires customers to have Cat5e or Cat6, Cat6a, or greater to run 100-base T networks. Fiber, of course, is an option, and wireless is also an option. For twisted pair, if you've got to rerun new cable to operate Ethernet over, the installation, inspection can be very costly. And of course, it's also very disruptive. And anytime you've got to rewire everything you're doing, that's going to take down your operations. Some of the biggest opportunities with the Ethernet extenders is due to the ability to avoid that disruption. Assuming you go through all that, you still also have to have to have your devices within a range of 328 feet. That's Ethernet spec, or 100 meters. Anything beyond that, it's really unsuitable for Ethernet. You have the potential for drops and just no connectivity at all. Fiber, it's hard to argue against fiber. It's wide open bandwidth. It's certainly future-proof, but it also suffers from the costly installs and inspections. Of course, it's disruptive. No different really than the twisted pair issues. And one of the big things about fiber that they haven't quite figured out yet is you can't provide power. And I mean like end-to-end power for UC endpoints. So I can't provide power for a remote device from my network closet to that remote device over fiber. Not yet. And then wireless is really the third alternative to giving network access to your remote devices. Not very disruptive. Certainly fairly easy to do, but it's not the most reliable technologies. Certain endpoints might be in locations where wireless cannot reach. There's certainly a whole lot of security issues involved with going into wireless. It's one of the biggest hurdles of really the IoT and the IIoT is figuring out how to really secure and what to secure in these wireless IoT applications. And just like fiber, wireless is unable to provide that end-to-end power for those Ethernet IP-enabled endpoints. Just get an idea on the cost in the DC area. We're about 30 minutes west of Washington, DC. Took some average numbers to try and figure out, what is this really costing us? How much disruption is involved in this? What's going to be my capital expenditure in trying to go network enabled or IP enabling my devices? When it comes to simple intra-building cable drops, you have drop ceilings, a cable drop like that. I mean, that's really the easiest possible type of cable drop. You're going to pay anywhere from about $150 to $300 for that drop. Tends to be fairly inexpensive. Where it can get really nasty is when you have to do any of the intra-building or any cabling that's going outside a building. So you want to wire up a campus for IP cameras or any number of things, running sensors, guard gates, access control panels, things like that. Anytime you start running outside, you start building trenches, it can be a real significant cost. And I won't go over any of these specifically, but this gives you an example on what costs are involved with doing so. With Patton's CopperLink Ethernet extenders, there's we are overcoming these type of hurdles. One, we can transparently pass Ethernet over any twisted pair or coax cable. This allows our customers or your customers to use their existing telephony circuits or old RS-232, 422, 485 circuits, even like alarm circuits, dry contact type circuits. If there is a twisted pair in the wall or running into a conduit, it is very likely we can give you high bandwidth IP connectivity on the other side of that connection. As far as reach, all of our extenders will certainly go well beyond the 328-foot limitation. We have some Ethernet extenders that can extend Ethernet up to 10 kilometers, or I think roughly around 6 miles of Ethernet extension. So we can cover just about any campus type application. And some of the newer stuff from Patton is now doing the power over Ethernet over the line or power over the line, and we're able to do that over any twisted pair or coax. So we're now able to provide end-to-end power over already existing cabling. Here's kind of an example, a small example of how that works. The network closet side, left-hand side, what we term our local units, are able to take the power in where power is readily available. the network connection and pass that over either RJ45. Well, you can connect either RJ45 terminal blocks or coax. We have all kinds of different connectivity options. And pass that data and power over to our remote side. That remote unit is what you're connecting to, the IP-enabled device. What that IP-enabled device will do is it'll take in that power, it'll regenerate it back up to PoE specs, so we hand off at our remote end a true power over Ethernet port. So it's the advantage of that, the significance of that is you can go another 328 feet from our remote unit. All the numbers that we give you will reflect the idea that you are going 328 feet beyond the remote unit. This particular unit can do up to PoE plus. So it can cover, I'd say, about 60% of the products out there right now for PoE, if not more. So the benefits of CopperLink are kind of some of the things that that we covered earlier. You know, Ethernet extenders are non-disruptive, very offer your customers a very cost-effective, quick, effective migration to Ethernet. Virtually unlimited distances. We can reach just about any point of a campus application, large campus. And you know, offering the PoE, I would really argue that the PoE is the greatest thing that Ethernet's come up with, and well, since its birth, is the idea of being able to power your device as well as give it, get access and control to that device over just a single cable over the same network is significant. It allows you to put, particularly like security, you can really put your endpoints anywhere you want, which can be very important when you're talking about, IP cameras and trying to cover, your buildings for security or a campus or things like that. It can be very beneficial. So what's the cost of using the Ethernet extenders? It's nothing. You're using your existing infrastructure. So you save there. What do these Ethernet extenders run? They vary because we have several different types. We probably have, I'd say, about 5 core different technologies for our Ethernet extenders. Looking at just kind of the 3 primary categories, a high-speed short range, the MSRP on a 2-pack, which is both a local and a remote, is 460. High-speed short range PoE is 465. When we're talking about high speed, we're talking 100 megs. And then a long range, which is the device that's going to get you out about 6 miles, will run you about 760 list for a long range Ethernet extender. For CopperLink, there's really 5 primary decision points when you're trying to figure out what kind of Ethernet extender you should recommend to your customer. I will always go over these whenever I get asked to help out a customer. If we know these 5 things, we can really get them into the exact extender for their purpose. The topology, how's the network laid out? Next slides will kind of cover that. Rate, how much bandwidth is actually required. That's always the trickiest thing to get out of the customer. A lot of customers will see, if they have a gigabit port, that's a very common one. They believe that that their bandwidth is actually a gigabit, where the application itself is nowhere close to a gigabit. We do not have gigabit ports on our current extenders. They're all going to be 10100, and that's because in truth the bottleneck, even if you have a gigabit Ethernet interface on our Ethernet extenders, the bottleneck is still going to be between the local and remote. We're not passing a gigabit extension, so that there's really no purpose to having gigabit on the LAN side connectors. The reach, how far does this connection need to go? The environment. For us, we typically have 3 types of Ethernet extender packages. There's the inside type of desktop modem. There's an industrial. So the industrial has a DIN rail option. So all your connectors are front facing, and it's got it's a 40 millimeter DIN clip for installation into a DIN rail. IP40 metal enclosure type of thing. And then we also have our boxes in IP68 enclosures, or IP67. My apologies. IP67 is really a weather resistant or a weatherproof enclosure. So it's protecting from rain, sleet, snow, any form of dust. None of that's going to get into the enclosure. There's glands for the cable management. It's fantastic for reaching, IP cameras. So you have IP cameras out in the middle of a parking lot. So solid device that you can put out there, and that you can go anywhere in that parking lot. And then management. What level of control do you want over these Ethernet extenders? All of our Ethernet extenders are plug and play, meaning that when you buy a kit, we sell our Ethernet extenders either individually, but the majority of the ones we sell are what we call our 2-packs, and that's a local and a remote. That's a pre-configured modem. So literally, when your customers purchase them, they have to plug in all the cables, plug in the power, and they're off and running. Everything is pre-configured. They don't have to do any type of management per se. That being said, as the number of devices and the number of applications grow using Ethernet connectivity, we get into more and more critical applications. The 5.9 type applications, the customers are really going to want to tighten the level of management. We have that on some of our devices. So we have anywhere from really an HTTP web page, SNMP type device, all the way down to dip switch, and now some of our devices actually have both. It's pretty cool. In terms of topology, these are fairly self-explanatory. Certainly anybody who's been into the old serial world are going to know a lot of these. We got the point-to-point, which is 2 Ethernet extenders, a local and remote, connected to each other. Typically, one is going to be on the network closet side, and then the other is going to be at the remote device, whatever the IP-enabled device you want to connect to your network will be. Then there's the ring topology. This is when multiple modems are forming a ring, and that's going to give you a redundant paths network. So if one path fails, it can go back around to the other. We have extenders that can handle that. And then the star. The star is when people have a single device, what we call our DSLAMs. They're going to be sitting in, once again, the network side, and be able to expand out to 24 individual CPEs. It offers a very clean solution as opposed to having 24 individual Ethernet extenders sitting in a network closet. And then we also have what we call our multi-drop Ethernet. So this is kind of the RS-422 type of replacement. So, the extenders, what they'll do is they connect back to back to back to back, both extending the overall connection as well as dropping off an Ethernet connection at each point. Show you a couple real-life examples of how those are used. And then the star plus the multi-drop. That's allowing us to use our DSLAM out to several different multi-drop CPEs. In terms of rate reach, here's kind of a chart. We won't spend too much time on it, but it shows you the wide variety of extenders that we have to meet the various different applications. You can get as high as 150 meg. at very, very short distances, 500 feet on in, or 192 kilobits out to 36,000 or 37,000 feet. So there's a wide variety covering just about any application you're going to run into. Just for simplicity's sake, the table on the next slide just covers all the various different rate reach numbers you see on the chart. It's a slightly easier to read chart. Here's the form factors I had discussed. Here's our indoor. That's our desktop. That's where our products are rated. I'd say 95% of them, certainly all of our Ethernet extenders, are rated 0 to 50 degrees Celsius as the standard indoor temperature or indoor units. When we have our light industrial units, you'll see for the majority of them, you'll see an E at the end of a number. So you'll see something like a CL1211E. That's denoting the industrial or extended temperature. These extenders operate at -40 to 85. When we give you a -40 to 85 spec, we're telling you that this is not only the operating, but the startup. It's very important difference. It's always worth asking if you're looking for extended temperature devices, if that's the startup or the operating temperature. Reason being is, say you lose power and -40 degrees, you get power back. If the modems aren't built to start up at -40, they won't start up. But if you've got the units working and the temperature drops down to -40, they will still work. So it can be a pretty critical difference. We're very careful on that. We do offer corrosion protection on our industrial products. The corrosion protection is a conformal coating we put on the PC boards. That's really going to prevent corrosion of all the various different copper traces. And it's really good for applications where you've got humidity or high salt levels in the air. Just an additional way to protect the devices long term. The third is the outdoor. The outdoor has the corrosion protection, and then that IP67. So that's where you get your dust and your water protection. These units in this enclosure can be submerged, but it's got a limited amount of time. I think it's somewhere in the neighborhood of 20 minutes at a certain depth. So it's really just safest to go. Say these are weatherproof type devices. I would not put them in a swimming pool for a long an extended time. And like the light industrial, the outdoors operate at the -40 to 85. The management is showing you an example of our PoE extender on the left. It's got very simple little dip switches. To hard configure rates, you can hard set these things down from 100 meg down to 10 meg. You can control a couple of different type of settings, whether you're connecting legacy PoE or PoE compliant type devices. So these are little things that you can set. And to the right is one of our managed extenders, and that's just kind of a very small example of the management those are capable of doing. Getting into the applications, the energy sector is a very popular place for our Ethernet extenders. We've done many different types of applications. This particular one is showing a nuclear power generator. This is one of those examples where there's always which benefits more important on the Ethernet extenders type of argument. One is the Ethernet extenders, the very name, right? It extends Ethernet. And the other biggest one is being able to operate over existing infrastructure. In this case, this was definitely the existing infrastructure. While the picture may not show you the full distance. Distance wasn't the major concern. The real problem was between between site 1 and 2 was previously RS-232 modems connecting into what they call dosimeter readers. These dosimeters read the amount of radiation workers were getting while working on a nuclear reactor. This particular power plant had a service coming up. They found that a couple of their dosimeter readers had gone bad, so they went to order a couple more computers. And what they got from the manufacturer were computers, but they were all Ethernet, no longer RS-232. There was no notice on the end of life or anything like that. So they had to find an emergency way to get Ethernet from point A to point B. The most obvious for them at first was really, okay, we got to run Cat5. We got to run some new conduits. But to be able to do something like that on a per line basis, so each dosimeter reader, they were looking at an expense of $550,000 to penetrate, reseal, and test fire barriers. The actual cable installation, installing the Cat5, the conduits, and the scaffolding, $350,000, and the excess materials around $100,000. So they were looking at about $1 million per line. This gentleman called us up, found one of our products on the webpage, and was just absolutely floored to find out he could take Ethernet over that existing infrastructure. We wound up doing additional lines. I think his total bill was about $27,000 as opposed to about $10 million actually having to redo that infrastructure. So significant cost savings using that existing infrastructure, and fast. We were able to do it overnight. Here's another example of kind of showing how you can use the existing twisted pair, reaching out to a guardhouse. We've done this for a couple of places where they decide that they're going to go over to voice over IP communications, right? They've already have an analog circuit running to all these various different buildings and guardhouses, and building entry points. There's already a twisted pair there. They've now gone over to voice. Rather than having to run a Cat5, assuming they're within the 328 feet, they can use that existing infrastructure, that same twisted pair, run it over an Ethernet extender, get anywhere from 10 to 100 meg bandwidth, depending on how far away they are from the operations center, and get 4 devices to be able to connect, over IP. So, security cameras, keyless entry pad, your phone, your voice over IP phone, and getting a PC onto the intranet. They're able to do all that over just that existing analog infrastructure. So they're not tearing up their campus, and they're getting just instant overnight benefits to IP. This one is an oil drilling application. Same thing. This one was really all about speed, trying to download the information from the drill as fast as possible. Money's time when they're drilling. So all the various different sensor data was being sent from the drill over the Ethernet extender into their box, so that the gentleman in the control room can make just lightning fast decisions in where to drill next, how to move the drill, whether or not he needs to pull the drill up. All those type of decisions can be made instantaneously without having to re-engineer their drill bit with new communications cables. Oil and water analyzers. This one, once again, this was an old analog system that they wanted to switch over to IP. They used the Ethernet extenders over the comms lines. This one went from analog to ADSL, and they now use the Ethernet extenders as like ADSL. Any old products that were using ADSL are really obsolete now. They no longer have point-to-point type of solutions for ADSL. Another energy type application connecting to windmills. This is using our multi-drop so that those PLCs that were running RS-45 kind of set in like a multi-drop type application can be converted instantly over to IP, just using these multi-drop Ethernet extenders, working over that same existing infrastructure. In some cases, we've also had customers who aren't replacing all their PLCs. We have there's serial PLCs. We have devices that are able to take their serial data and convert that over to Ethernet or IP. So we have device servers that allow you to do that, and a device server in conjunction with the MDE allows them to set up and be ready for IP and actually enjoy all the benefits of IP without replacing the endpoint or the serial PLC. Here's one in the US that can be really near and dear. This one's for EMV. That's that Euro, MasterCard, Visa, little metal chip that you have on your credit cards. So the US was very slow in adopting this standard. It was about 2 years ago where all stores, indoor POS systems for stores have mostly converted over. The whole thing was both MasterCard and Visa, these credit card companies said, no more, we're not going to be responsible for fraudulent transactions. We're using this technology. If retailers choose to, build their POS systems to use this, they will prevent the fraud. If they don't, then the onus is now on the retailer to pay those fraudulent charges. So for internal POS, it was about 2 years ago where the cutoff was. For outdoors, it was just a few months ago. And those outdoor POS systems, they gave the outdoor POS systems additional time because it's very difficult and costly to reach those ATMs or for gas stations, those pumps. You tear down a gas station, you take out the concrete or anything in that forecourt where those gas pumps are, people are going to pass up your gas station. If they pass up the gas station, it's not really a big deal, in terms of selling the gas, but it's going to kill you and selling the sodas, the candy bars, and all the other good stuff that they get you with anytime you go fill up your car. So using the Ethernet extender, we're able to, all those pumps are running on RS-45 cabling. So it's all twisted pair running from, what we show is one, running from the office to these pumps. So we can use an Ethernet extender, one on both ends, or a device capable of doing a SAR out to multiple pumps, and provide that instant IP. So EMV really it doesn't absolutely require Ethernet, but it's really slow without it. So it's definitely worthwhile upgrading the system, and in doing so, you're getting the benefits of the extreme high bandwidth. You're no longer limited to the RS-45, 6 megish, I think maximum line rates or data rates. You're now talking, 100 meg, easy. No, there aren't that many gas stations that are going to go more than, I'd say, about 1,000 feet from the office to the pump. So you're offering full 100 meg bandwidth from the office to the pumps. And what that allows them to do is all the other cool POS systems and videos and things that you see on some of the modern gas stations today. So you can do quite a bit and save these guys a whole lot of time and money in allowing them to use that existing infrastructure. For security, we do this particular one was for a gas line. It was a gas pipeline. This particular company was responsible for monitoring and maintenance of the pipeline. They were having issues with people, say a little over a mile away. They were interfering or stealing, I guess, equipment and damaging the pumps. So they wanted to run security cameras out there. They had these AXI rugged outdoor IP cameras that they wanted to use, but Ethernet's 328 feet. So when able to use those cameras, they needed something to extend that Ethernet. We used our at that time that was our model 2173. They've since gotten a whole lot better, but we're able to extend that Ethernet. At the time, we had the weatherproof enclosure, but we didn't have the built-in PoE functions. So we built a custom box, which we do a lot of custom work here, that was able to hold both a PoE injector as well as an Ethernet extender, so we could get that network extension and give the PoE injection to the AXI rugged outdoor camera. It just happened so that they did have AC power out where we needed it. In today's application with our new CL1101, you wouldn't need to have that power circuit out there. I mean, we were really lucky that they did. It made life a lot easier, but we would no longer require it with today's extenders. Here's kind of the same example of what I had shown earlier. This was a nuclear power plant, and they same thing as a prior customer was really just looking at switching their phones from analog to IP, and they took advantage of doing that using our Ethernet extender. So they were able to get their IP phones as well as IP connectivity to several other devices. Elevators are a really cool application. We've operated off of some pretty amazing elevator cable where you would never think Ethernet could pass over. We've done them. Fairly recently did a hotel in Dubai where these were really fantastic elevators. They wanted the full-on video in the elevators, and the IP phones, the card readers. So somebody slides in the car and it tells you exactly what floor you can go. It's kind of security measure, as well as IP cameras. They had two-wire twisted pair that came out of the this Belting cable block, and we took advantage of that and provided each elevator 100 meg bandwidth from the elevator control room down to the actual elevator itself. This is really a great example of IoT type of application that is not wireless. For traffic and transportation, we've been a long-time supplier of network connectivity to the Czech railways. We do a lot of their stations. They certainly do have fiber between some of these train stations, but there are a lot of train stations where they can't justify the cost of running fiber, running those trenches out, but they already had telephone connections between all the various different stations. So for the less populous train stations, they use our extenders to provide that network connectivity. Transit, Metro Transit, as more and more devices go, this is where we get into the IIoT or the industrial Internet of Things. As more serial enabled endpoints switch over to IP, more and more, that gives us more and more opportunities with the extenders. So, Metro Transit or New York City Transit wants to start converting their devices over. They can use our extenders without having to actually tear up their infrastructure, and we have done a couple installations with them in this type of application. Then one that's very near and dear to our heart is we're right here in Maryland. We do all of our manufacturing in Gaithersburg, Maryland, USA. So it was a big victory being able to do a project with the Maryland State Highway. So now I know if I get to a traffic light and there's an issue, I can kind of blame myself or my engineers for it. But it's pretty cool. So at each intersection, they have our multi-drop Ethernet extender, and they're providing really IP connectivity to each one of these boxes. These boxes connect to the light system, the cameras, all the control. The advantage to these type of systems is now from the headquarters they can control, monitor all the various different traffic elements. Previously, it took somebody actually to do a truck roll or go into the central intersection and sit there and configure or download or run different programs into these boxes. Now they're all connected over IP, and it can be done from the headquarters. Campus applications, really basic. The Ethernet extenders can be used to provide backhaul, trunk lines to various different buildings within a campus. We've got the best extenders for that type of thing. Certainly the long distance ones, we have Ethernet extenders that can bond anywhere from 2 to 4 pair, giving you a really high 60 meg symmetrical bandwidth connection between the two endpoints and a pretty far reach, and buildings that are really close to the the IT building or wherever that DMARC is can get up to 100 meg symmetrical using our other extenders. Recent application that we've just really kind of finished up doing the rest of the installations is for the U.S. Coast Guard. The U.S. Coast Guard's got a Ethernet extender in every single one of their cutters, and at each Coast Guard port, they are using our DSLAM, and that's really to operate over their old existing cabling. They've got these big power plugs that they take from the dock, plug them into the boat. Inside that big plug is some data cables, so they're able to download their mission information as well as get mission information over that cable. That was our most recent, really fun application to install.
All right, great.
And that's a wide variety of applications. Hopefully it's given you some ideas and you've had customers who have had these type of things. There are many different things that we can do with these Ethernet extenders in terms of size and type of cabling to work over. We've really become experts at all these various different transport methods. So, feel free to contact myself or Jen should you come across any of these.
Great. Well, thank you, Johnny. I know I'm pumped to sell some Ethernet extenders. Does anybody have any questions that we can address at this time? Leave it open for a minute or so. If not, you can contact me, send your questions to Jen, that's JENN @patent.com, and I will be happy to address them. We'll leave this questions open for another minute, and if not, we will go ahead and conclude the webinar. All right, it looks like we don't have any questions. So at this time, we're going to go ahead and conclude this webinar. Thank you all for joining. And we will have this posted on our website for review if you guys need it. You can also contact me and I'll send it as well. Thank you for joining, and I hope to see you next month for the SmartNode overview. Thank you.